Hi there, so this is my question. So basically, you can see the question up here. Let f of x equal cos x over sine x. And then it asks you to use the quotient rule to show that the derivative of that is -1 over sine squared x. So to begin, write the original equation right here, and then you use the quotient rule as it so plainly states. And so you take the derivative of the top, so cos x, the derivative of cos x is negative sine x, times the bottom, sine x. And then you subtract the top, cos x, multiplied by the derivative of the bottom, and the derivative of sine x is cos x. So here's the derivative of sine x. And then you divide that whole thing by the bottom squared, so sine x squared. And note that the squared is outside the bracket. It's not applying to the x, it's to the whole thing. So, by distributing over here, you get negative sine x times sine x, which is negative sine squared x. And then you subtract cos x times cos x, which is cos squared x. And then you divide that whole thing again by sine squared x. Now, we have to remember this looks kind of like an identity, this one over here. So first we're going to factor out the -1. So we factor out a -1 on the top, and we end up with this equation right here. And now we go over here and we remember that sine squared x plus cos squared x equals 1. So that goes in there. And so that whole bracket just gets replaced by +1. So -1 times +1, again, -1 over sine squared x. And that's what the question asks for. Here's the second part of my question. Part B, it asks you to find the second derivative of f of x, which f of x was cos x over sine x, and the first derivative of that is -1 over sine squared x. Now, to find the second derivative, it may be easier to think of this 2 out here, because so first we distribute it, so the first thing to do would be to put everything in one line, as seen here, so that we can do the whatever product or chain rule, I think it's the product rule, to take the derivative. So once you get, obviously, since it's on the bottom, negative 2, and that's where you start. So the first thing you do is take the exponent, multiply it by in front. So this 2 multiplies down, the -2 multiplies by the negative sign, you get +2. And then you subtract 1 from the exponent. So it's -2, you fill in the bracket as the same, subtract an exponent, you get -3. And then you multiply that by the derivative of the inside, and as we saw, I think in the previous question, and as we've been learning, derivative of sine x is cos x. So then you end up with 2 sine x to the -3 times cos x. And then again, this sine x to the -3 goes on the bottom. The 2 stays on the top. The cos x stays on the top. And you're left with 2 cos x over sine x to the 3, which is the answer. And then I thought it didn't look right, so I went further. And apparently cos over sine is the same as cotangent, which makes sense. Only listen to this next part if you're really intrigued, but cotangent is, or since tan is sine over cos, cotangent, which is the inverse, or 1 over tan, would be cos over sine. So you can take out a cotangent here, and then sine or cosecant, right here is 1 over sine, so since right here is 1 over sine, you can turn it into cosecant and bring it up to the top, and you're left with 2 cos x, or cot x, times cosecant squared x, and that is it.